Yes, good evening, guys. Can you hear me? Am I audible online? Online, can you hear me? Am I audible? Right. Okay. Sorry for the delay. Because of some technical issue, it got delayed today. Right. Okay. So let's get started. So, side heading, make a note. Good evening, guys. Aishwarya, good evening. Mahi, good evening. Subhanshu, good evening. Subhanshu, right. Guys, switch side heading. So, coming to switches, good evening, guys. Good evening, Chandu, Rajesh, Chandan. Right. Okay. Arif, good evening, guys. Sir, shall. So this is basic AWS ma, right? Okay. So make a note. Switch side heading. So coming to switches. So we have two types. So we have two types of switches. One is manageable switch. Another one is unmanageable switch. Manageable switches, unmanageable switches. Got it, guys? Do you know how the switch it will be looking? It's looking like hub. Yesterday we discussed about hub, right? So switch also it will be looking like hub only, but more than hub. This is actually it's a advanced technology, right? So coming to switches, we have two types. One is manageable switch, another one is unmanageable switch. Got it, guys? So coming to real-time environment, we are going to use manageable switches. Okay. So we are going to use manageable switches. If you go to any data center, so in the data centers, we'll have manageable switches. So usually if you go to any small organization, right, maybe 15 to 20 people, they are working into that organization. Like this people, they are going to use unmanageable switches. Both are same, but caste wise, technology wise, a little bit different. So coming to manageable switches, it's bit expensive. So minimum 20,000, 24,000 like this will have manageable switches. Coming to unmanageable switches, 4,000, 5,000 like this will have 15 port switch, 20 port switch like this will have, right? So like hub, unmanageable switches like hub, but it will act like as a switches. So small industries like 15, 20 people strength will have in that particular organization. Those people, they are going to use unmanageable switches, right? So if you go to data center, so we'll have the hundreds of the peoples into our organization. Those kind of organization, they are going to use manageable switches. Whatever it may be, the working style, everything is same. So first point, it's an intelligent device. First point, it's an intelligent device. It's an intelligent device. Like you people, you're all intelligent people, right? Huh? So guys, Cisco switches are very famous. So this is Cisco switch. See, Cisco, right? And Netgear, like the switches will have. So different brands are offering switches. So this is, I think, so 28 port switch will have, 48 port switch will have, 32 port like this, different port switches will have. Got it, guys? This is Cisco switch. So first point, it's an intelligent device. Second point, it will maintain MAC table. Second point, it will maintain MAC table, MAC, MAC. Yesterday we discussed na MAC address. Like the same way, so it is going to maintain MAC table, MAC, MAC table. Second point, it will maintain. It is going to maintain MAC table. Third point, uses flirting, uses flirting and broadcast for communication. Sorry, guys, unicast for communication. Flirting and unicast. Flirting and unicast for communication. Yesterday, we discussed about broadcasting, right? So today, floating and unicast. Floats, we are going to say floats, right? So floating and unicast. Unicast for communication. Third point, floating and unicast for communication. Fourth point, each port having Fourth point, each port having fixed bandwidth. Fixed bandwidth. Fourth point, each port having fixed bandwidth. Each port having fixed bandwidth. Fifth point, having full duplex communication. Fifth point, it having full duplex communication. Can I repeat? First point, it's an intelligent device. Second point, it will maintain MAC table. Second point, it will maintain MAC table. Third point, uses floating and unicast for communication. Floating and unicast for communication. Third point, floating and unicast for communication. Third point is important. Floating and unicast for communication. Okay. Fourth point, each port of the switch having fixed bandwidth. Each port of the switch having fixed bandwidth. Each port of the switch having, this is one port right here in the switch. This port having fixed bandwidth. Got it, guys? Fifth point, it having full duplex communication. Very good, right? Simran, good. So if you remove S, that is my name. Huh? So Imran, if you add S, it will become Simran, right? Okay, so got it, guys. Right. So this is switch, guys. It will be looking like this. It's a bit expensive. More than 25,000 like that we'll have. Right? Cisco switches are very expensive. It's a very popular. So usually in our data center, maximum people, they are going to use Cisco switches only. Right. So let's see, guys. First point. Assume this is switch. Instead of hub, we are using switch today. Right? This is switch. With the help of the switch, we deployed one network. With the help of the switch, we deployed one network. So how many missions we have in this network? 4 mission. 4 mission network. So this is total one network. We deploy 4 missions into this network with the help of centralized device called switch. First point, it is an intelligent device. It's an intelligent device. Why it is an intelligent device? Now we are going to discuss. Guys, same scenario. Yesterday what we discussed with hub, same scenario. This is source mission, mission 1. And this is destination mission, mission 4. This is source mission and this is destination mission. Mission 1, guys, please focus. So mission 1, it's try to sending the data to mission 4. Mission 1, it's try to sending the data to mission 4. Mission 1, it will send the data to switch. Got it, guys? First, mission 1, what it will do? It is going to send the data to switch. Switch, what it will do? It will capture the mission 1's MAC address. Already we know very well about MAC address. Yesterday we discussed about NIC cards. Inside the NIC card, we'll have MAC address, physical address, hardware address, Ethernet address, whatever if you want to can call. So sender, he's trying to sending the data to mission 4. This guy is a sender. This guy is a receiver. Got it, guys? This is source mission and this is destination mission. Source mission, it's trying to sending the data to destination mission. Source mission, mission 1, it's trying to sending the data to switch. Switch, what it will do? It will capture the mission 1's MAC address. Got it, guys? So mission 1 MAC address, it will capture by switch. It is going to maintain the MAC address table. It is going to maintain the MAC table inside the switch like this. Inside the switch, it will maintain the MAC table. First mission MAC address, it is going to capture. It is going to store into the MAC address table. Got it, guys, as of now. Right? Mission 1, it's trying to sending the data to mission 4. Mission 1, first, it need to send the data to switch. Switch, what it will do? It will capture the mission 1's MAC address. It is going to maintain inside the MAC table. MAC table, right? So now the switch, what it will do exactly? The switch, it will send the data to mission 4, mission 3, and mission 2 apart from mission 1. This is called floating. One to many excluding source. Broadcast is a different, floating is a different. Broadcast means one to many including source. Floating means one to many excluding source. I hope you got it, guys. So mission 1, it is not going to receive the data, right? Switch, it will send the data to mission 4, mission 3 and mission 2, but it is not going to send the data to mission 1. Who's the right person? He will accept the data. Remaining people, they will drop the data in hub also with the help of one protocol. So who's the right person? So he's going to accept the data. Remaining people, they will drop the data. For example, what is your name? Your name? Harish. Harish. H. Harish. Okay. So we have one student called Harish into our classroom. Okay. Your name is Harish, right? So he's very much like doing tricking kind of, right? Got it, guys? You have Thar, assume that. You have Thar, you need to do the off-roading. So usually off-roading where he's going to perform into remote area itself only, right? Yes, no? Into remote areas itself only, we are going to perform the off-roading, right? Yes, that guy is a rich guy. He have the Thar, man. So that's why he's doing off-roading. So into one remote area. Okay. Past 10 to 15 days onwards, he's staying into remote area. There is no signals, phone signals. There is no internet. There is no phone calls. Then he's missing their parents. For example, yes, no. You're going to miss your parents, right? So you are from Bihar. Okay. So especially in Bihar. Okay. So he belongs to Bihar. I don't know much about those all the areas. Okay. Got it, guys. Okay. So for example, he's into remote area. He's missing their parents, his parents. And then what he's going to do, how he's going to communicate with their parents with the help of postal service. Postal service, letter. There is no phone calls. There is no internet. Nah. How you are going to communicate? So that's why what you are going to do, you are going to write the letter. With the help of postal services, he is going to send the letter to his parents, right? Okay. Guys, he's going to write the letter. He's going to post the letter. The letter, who's going to carry to his home? Postman. Okay. In Bihar, one new postman, he got appointed. He don't know much about Bihar. Guys, assume that one new postman, he got appointed into Bihar. He don't know much about Bihar, right? So he need to visit to Harish home, right? So he don't know Harish home, where it got located. Then how he's going to find? He's going to read the address and then he's going to ask one by one first time. That's it now. One by one first time. Finally, he's going to find the Harish home. I hope you got it, guys. Like the same way, this guy, while he's trying to sending the data to mission 4, mission 1 MAC address, it is going to capture by switch and is going to store into the MAC table, right? Switch, what it will do? First time, switch is a new guy, new postman. So this switch, what it will do? It will send the data to mission 4, mission 3 and mission 2. But who's a right person? They are going to accept the data. Remaining people, they will drop the data, right? Yes, no. Again, after 20 days, Harish is writing one more letter. So this postman, he's not going to search next time. Directly, he's going to visit to the Harish home and then he's going to deliver the letter. Yes, no. Like the same way, mission 4, he's tried to providing the response to mission 1. Mission 4, MAC address, it will capture by switch. It is going to maintain into the MAC table. And switch, he know already mission 1's MAC address. So that's why request and response, it will happen one-on-one. Next time onwards. I hope you're clear, guys, now. What is floating and what is unicast. So switch having the mission 1's MAC address already. So that's why switch next time onwards, it is not going to send the data to each and every mission. So it is going to send the data to directly to that particular person. That is called unicast communication. So inside the switch, you need to configure the switch. If you try to accessing the switch, so we can find the MAC table. I'm not going to cover those all here because that is all belongs to CCNA routing and switching. We have one course called CCNA routing and switching. So there we are going to cover how to get the MAC address, how we need to verify what kind of MAC addresses we'll have into the MAC table, everything. So it's not that much of easy. Theory is important for us, how it's working, because we are not going to use any switches into AWS. We are going to use virtual. So that's why you should understand the functionality. No need to bother about configuration. Just functionality is enough, right? I hope you got it, guys. So sender's MAC address, it is going to capture by switch. It is going to maintain into the MAC table. With the help of this MAC table, directly second time, it is going to send the data to particular person. That is called unicast communication. I hope you are very clear about third point. Coming to fourth point, each port of the switch having fixed bandwidth. For example, 40 Mbps bandwidth will be connected to the switch, right? So the switch, what it will do, it is going to provide the 40 Mbps for mission 1, 40 Mbps for mission 2, 40 Mbps for mission 3, and 40 Mbps for mission 4. We are not going to lose the bandwidth like hub. Got it, guys? So hub, usually it is going to share the bandwidth. Then we are going to lose the bandwidth here. But switch, it's not like this. It is going to provide the fixed bandwidth. So mission 1 also having 40 Mbps. Mission 2 also having 40 Mbps. Mission 3 also having 40 Mbps, and mission 4 also having 40 Mbps. So that's why in real-time environment, maximum 99% people, they are going to use switches instead of hubs. So why it is an intelligent device? One-on-one communication we have, unicast communication. So because of MAC address, unicast communication, it's happening. So that's why switch is an intelligent device. But hub, it's not an intelligent device because hub doesn't have any MAC table. Every time it is going to spread the data to each and every mission. Got it, guys? Hub having broadcast communication. Na? So that's why every time it is going to share the data to each and every mission. And then only that particular person who's the right person is going to accept, reminding people they will drop. So that's why most of the people, they're not going to use the hub into the real-time environment because it having broadcast communication. If you're having more broadcast communication, the network, it is going to become slow. I hope you got it, guys. Clear, right? Okay. So coming to fifth point, full duplex communication. Request and response, it will happen at a time. So request and response, it will happen at a time. I hope you're clear, guys. So simultaneously, it will happen request and response. Quickly, we are going to get the reply. Yes, switch, it is going to store the MAC address table. It is going to remember. So got it, guys? Good. So this is all about switch functions. Coming to routers. Guys, without routers, without switches, you are unable to understand the VPC. In VPC, we'll have the routing table. If you need to understand the VPC routing table, definitely you should know about routers. Got it, guys? Make a note. Side heading. Router side heading. First point, it's an intelligent device. Router also intelligent device. So first point, it's an intelligent device. First point, it's an intelligent device. Second point, it will maintain the routing table. Second point, it will maintain the routing table. Got it, guys? Second point, it will maintain the routing table. It will maintain the routing table. Third point, it will enable the communication. Third point, it will enable the communication between two different logical networks. It will enable the communication. Third point, it will enable the communication between two different logical networks. Fourth point, it will decide the best path to send the data. It will decide the best path to send the data. It will decide the best path to send the data. In brackets, path determination. Path determination. First point. Fourth. So it will decide the best path to send the data. So in one word answer, path determination. That's it. Got it, guys? It will decide the best path to send the data, right? Let's see, guys, here. Usually, how the switch it will be looking. Sorry, router, right? Cisco routers are very famous. See, guys, this is router. This is router. This is front view, and then it's a back view. 1 minute. See, guys, this is front view, and it's a little bit old router. This is okay. This router, it having power card like our PC. How our PC will have power card, like the same way router also. Router and PC similar devices. PC and router both it will work same, right? So this is power card, and we'll have power switch, right? And we'll have auxiliary port and console port, auxiliary port and console port and serial port. With the help of auxiliary port, we are going to access this router remotely into our laptop. We are going to configure. Those all the configurations, it will be covered under CCNA routing and switching course. Just for understanding purpose only, right? So this is a router usually. So router means in our home also we'll have Wi-Fi routers. Wi-Fi router, that is also it will work like that only. But in real-time environment, we are not going to use our Wi-Fi routers. We are going to use like this router, Cisco routers only in real-time environment. We need to configure manually each and everything, IP addresses, and then port security, everything we need to configure. Routing table, everything, not routing table, and dynamic routing protocols, everything we need to configure here. Got it, guys? I hope you're clear how the router it will be looking, right? So usually in our diagrams, we are going to use like this symbol. This is router symbol, guys. Okay. Full duplex stations. Data simultaneously it is going to share. Got it, guys? Request and response, it will happen simultaneously. Right. So let's see, guys, here. So this is router. This is one network, and this is another network. Guys, if you're investing crores of the investment on physical network, there is no use. Maybe you purchase routers, switches, cables, and multiple PCs, everything. You deployed one network into your organization. That is not useful. Without IP addresses, without logical address. Without logical address, there is no use with physical environment. I hope you got it, guys. This is one physical network, right? This is one switch, and we connected 4 machines with the help of the switch, and this is one network. Assume this is one LAN. So it's available into second floor. Okay. And this is another LAN. This is available into another building. I hope you got it, guys. So it's available into this building, second floor, and this LAN, it's available into maybe new campus, 5th floor. Got it, guys? So we establish the media between those both the networks. Got it? So we establish the media between those both the network. You are unable to send the data. You are unable to receive the data from this network to this network and this network to this network, because those all physical networks. That's it. There is no logical network. Without logical network, you are unable to communicate. For example, you need to send the data from mission 1 to mission 4. Without logical network, IP addresses, we are unable to send the data. Simple, ma. I need to communicate with you people. Without your contact number, can I? You need to communicate with me. Without my contact number, you are unable to communicate, right? So our mobile number is a logical communication channel. I hope you got it, guys. Our mobile number is a logical communication. It is going to enable the logical communication in between you and me. So without knowing our mobile number, how we are unable to communicate? So without logical addresses, without IP addresses, we are unable to communicate each other here. So that's why we need to assign the IP addresses. Now I'm going to start about IP address. Don't worry. Okay. So now we are going to assign the IP address. So this network, logical network is 192.168.1.0. This network, logical network is 10.0.0.0. Don't worry, what is 192, what is 10, everything you are going to understand thoroughly. Got it, guys? So now we are going to assign the IP address 192.168.1.1, 192.168.1.2, 192.168.1.3, 192.168.1.4. IP addresses are unique. How our contact number, mobile numbers are unique, like the same way in one network, IP addresses are unique. Got it, guys? With the help of IP addresses only, we are going to send the data, we are going to receive the data. So this is different network and this is different network. Got it, guys? This is 10.0.0.1 and this is 10.0.0.2 and this is 10.0.0.3 and this is 10.0.0.4, like that we are going to assign. Now, from this mission, from this network to, I need to send the data to this network. For example, this mission 1, it need to send the data to this mission 1. I hope you got it, guys. So directly, it's not possible. Simple. Assume this classroom is 192.168.1.0. We are all computers. I'm having my IP address 192.168.1.1, my IP address. His IP address 192.168.1.2. That guy IP address 192.168.1.3. That guy IP address 192.168.1.4. Like this. How many peoples we have? 200 peoples we'll have in our classroom. I hope you got it. Yes, no. If I need to communicate without my contact number, I'm unable to communicate with you. Yes, no. Like the same way, simple. Remember, MAC address is your postal address. IP address is your contact number, phone number. Got it, guys? How one person, he have the two different addresses. Like the same way, if you go to network, one mission, it having two addresses. One is MAC address, that is physical address. Another one is IP address, that is logical address. Without logical address, we are unable to communicate. So now we are unable to send the data from this network to this network and this network to this network. So how we need to enable the communication? Second point. I think third point, right? It will enable the communication between two different logical network. This is one logical network. This is another logical network. Simple. We have one classroom here and one more classroom there. I think not here, second floor, I think so. So two classrooms we have now in second floor. So classroom 1, classroom 2. So can we communicate from classroom 1 to classroom 2 directly? Is it possible, guys? Then how we need to communicate? We need to make a one small door in between both the classrooms. The door is a router. I hope you got it, guys. So this is router. What it will do? It will enable the communication between this network and this network. So without router, we are unable to communicate directly. I hope you got it, guys. We can communicate into our classroom itself only. We are unable to communicate with another classroom people. So if you need to communicate with other classroom peoples, what we need to do? We need to make one small door here. Then only we are going to make a communication, right? So this door, it will act like as a router. So router, it will enable the communication between two different logical networks. Got it, guys? Right. So now coming to this diagram, this is Hyderabad network. Assume this, Naresh Shetty having two different branches. One is in Hyderabad and one more is in Chennai. Got it, guys? So this is Hyderabad network. We have few missions. Those all the missions it's connecting with switch. The switch we connected to router. This circle is router, guys. Got it? So this is one router. This is one network. This is Hyderabad network. And this is Chennai network. So now Hyderabad people, they try to sending the data to Chennai network people. I hope you got it, guys. From Hyderabad branch to, I need to send the data to Chennai branch. So this is internet. Okay. So we have two different routes to send the data, right? Got it, guys. This router automatically, it is going to capture the neighbor's router's IP addresses. So this router IP address, this router IP address, automatically it will capture. It is going to store into the routing table. Automatically. We have one concept called dynamic routing. With the help of the dynamic routing concept, it is going to capture both the IP addresses and will store into the routing protocol. I hope you got it, guys. So now this router, Which one is a best path, guys, to send the data to Chennai according to this diagram? Above one or below one? Below one. Why below one? We have only one router this side, one hub, and we have two hubs. For example, you need to travel from Hyderabad to Chennai. So how you are going to travel? With the help of Google Map, right? So we are going to ask to Google Map, boss, please provide the shortest route, because we need to save money. We need to save petrol. Yes, no. Like the same way, router also, it will decide the shortest route, right? So router is an intelligent device, right? So it's not a human, right? Maybe it's an intelligent device, but it's not a human, right? So humans, they have the sense. So that's why they are going to decide, okay, so and so route is the best route to travel. But router, how it is going to decide? With the help of routing protocols. What is that? Routing protocols. Got it, guys? Coming to routing protocols, we have RIP. RIP means what you are thinking, that is not that RIP, okay? RIP stands for Routing Information Protocol. RIP stands for Routing Information Protocol. If you want, you can make a note. Nowadays, no one they are using RIP. Okay, what is protocol? You should not ask like this question, man. You are all belongs to IT. What is protocol, guys? Protocol is a one piece of software. It will bounded with few set of rules and regulations. What it will do, it will carry the data from one place to another place like as a postman. Yes, no. Protocol is a one piece of software. It will bounded with few set of rules and regulations. Exactly protocol, what it will do, it will carry the data from one place to another place like as a postman. I hope you got it. For example, assume this, my body is computer, right? So I'm a computer. So now I'm trying to sending the data, means I'm trying to teaching to you. How I'm trying to teaching? With the help of my voice. That's it, na? Yes, no. So that is protocol. Clear now? So we have multiple protocols, right? Multiple protocols like DHCP, DNS, HTTP, HTTPS, FTP, like this many protocols. Coming to routers, we have routing protocols. RIP is a routing protocol. So routing information protocol, this is a very old protocol. It's a very old protocol. No one they're using from route. Excuse me, guys. So CCNA version 3 onwards, no one they're using RIP. Okay. Then EIGRP. EIGRP stands for enhanced interior gateway routing protocol. Enhanced interior gateway routing protocol. EIGRP stands for enhanced interior gateway routing protocol. OSPF stands for open shortest path first. Open shortest path first. OSPF stands for open shortest path first. I hope you got it, guys. Guys, we should not configure all the protocols here. We need to configure only one. If you are trying to configuring the multiple protocol, it won't work. So you need to configure RIP or EIGRP or OSPF. Got it, guys? For example, if you configure the RIP here, what will happen in the sense? RIP, it will work depend on hop count. Least hop count, it will consider as a shortest path. One hop means one router. Least hop count, least router count, it will consider as a shortest path. So if you configure the RIP, this is a shortest route to send the data to Chennai. I hope you got it, guys. If you configure the EIGRP, Enhanced Interior Gateway Routing Protocol, this protocol, it will decide the shortest path depend on bandwidth. More bandwidth, it is going to consider the shortest path. For example, this side we have 100 Mbps speed, but this side we have 1000 Mbps. So EIGRP, it will consider this is the best path. I hope you got it, guys. Clear? So OSPF, open shortest path first. This is a successor of RIP. So RIP, it will consider only 99 hops only. More than 99 hops, it is not going to send the data. So we'll have many drawbacks in RIP. So that's why they avoid now and they introduced to us OSPF instead of RIP. This is a successor of RIP. I hope you're clear, guys, about routing protocols, right? Routed protocols. Routed protocols. Routed protocols means routing means continuation. Routed means finish. Completed. Right. So coming to routed protocols, IP. You know IP, na? Internet protocol. IP, IPX, Apple tag. Normal machines having IP. IBM machines having IPX. IBM machines having IPX. Apple tag, you know. Apple computers having Apple tag. Nowadays, IBM and Apple peoples also, they are using IPs only. I hope you got it, guys. Right? So who's going to share the data between those missions? Routed protocols. Got it, guys? So who's going to share the data? With the help of IP addresses, we are going to share the data. So IP is a routed protocol. So this mission having one IP address, with the help of that IP address, it is going to share the data. I hope you got it, guys, about routers. Clear? So this is all about network hubs, switches, and routers. Why I have given this much of information in a sense, you should not have the doubts while we are discussing about VPCs at the time. Got it, guys? Right. Now we are going to start new concept called IPv4. IPv4. Let's see, guys, here. So this is very, very important concept. Please focus on it. As of now, just we discuss about only network devices, right? Without logical address, you are unable to deploy the network. So your purchase like switches and routers, everything with the help of cable, you deploy the network. That is not enough. So we need to provide the proper logical network. Then only it will act like as a network. So without IP address, it's impossible. Without IP addresses, it's impossible. So that's why we are discussing about IP addresses now. So guys, coming to IP address, guys, please focus. From now onwards, please be serious, okay? So we'll do like jokes also we'll do, and then we'll make fun also. But this is very serious session. Without knowing this, we were unable to understand the AWS concept. So that's why please try to understand. I'm requesting you. I'm not like forcing you people, right? Got it? Try to understand, right? So because of you only we are here, right? So coming to IP addresses. So we have two versions, guys. One is IPv4, means IP version 4. Another one is IPv6, IP version 6. Anyway, we are not going to discuss about IPv6. No one they are using. Why they are not using, I'll tell you, don't worry. Okay. IPv4 and IPv6. IPv4 stands for IP version 4. It's a 32-bit addressing. This is a 32-bit addressing. 32 bits means 32 zeros and ones. 32 bits means 32 zeros and ones, right? How many combinations we have in IPv4? How many combinations we have in IPv4? Guys, this is a formula. 2 to the power of 32. 2 to the power of 32 bits. Got it, guys? This is a formula. 2 to the power of 32. How many combinations we have? More than 4 billion combinations we have. Those all the combinations, it got over. Finish. We doesn't have the IPv4 combinations nowadays. Those all the combinations got over. Why it got over? Because of us. So multiple people, they are trying to maintaining the multiple smart devices, right? All the smart devices, it will work depend on IP addresses. Your smart mobiles. If you go to one person, that guy is going to maintain the three smart mobiles. One for business, one for personal purpose, one for another purpose. Huh? Yes, no? Right? So, three smart mobiles means three different IP addresses we require, right? So simple. So exactly, nowadays, most of the people, they're using smart gadgets. So those, all the smart gadgets, it will work depend on IP addresses. Like our smart AC, smart television, even smart washing machine also will have, man. I don't know why smart washing machine. We need to put the clothes manually only, na? So automatically it won't come, right? So I hope you're clear, guys. So we have smart devices. Those, all the smart devices, it will work depend on IP addresses, right? For example, we have one smart CC cam here. We have one smart CC cam here, right? Outside. Yes, no. So for example, we deploy one smart CC cam to monitor the people. So then how you are going to communicate with smart CC cam? With the help of smart mobile. With the help of smart mobile. We need to download the smart CC cam app into our smart mobile. With the help of this app, we are trying to communicating with that particular smart CC cam. So smart CC cam having one IP address and your mobile also having one IP address. With the help of those both the IP address, the communication it will happen. Then we are going to get the visuals from the smart CC cam to into your mobile. And if you want to can download the visuals, if you want to can download the videos from the smart CC cam, you can monitor the people. I hope you got it. If you go to smart homes, okay, Google, close the curtain 100%, open the curtain 50%, like this devices also will have. Switch off the fan, switch off the AC, like this devices also will have. Those, all the devices, it will work depend on IP addresses. So that's why IP address, IPv4 IP address combinations, it got over. If you doesn't have the IP addresses, then how you are going to communicate with smart devices? So that's why they introduced to us IPv6. I hope you got it, guys. IPv6 is a 128-bit addressing. 2 to the power of 32 whole power 4. Means compared to IPv4, in IPv6, we have 4 times more IP addresses. Even if you want to can like share the 1010 IP address for throughout world, how many people will have for them? Even though you'll have the IP addresses into IPv6. I hope you got it, guys. The differences between IPv4 and IPv6. Why IPv6 is 128-bit? Why not 64? Why not more than 128-bit? IPv4 is a 32-bit. Okay. Why IPv6 128? Why not 64? Okay. If they introduce a 64-bit, maybe in future we are going to face same issue, shortage issue. So that's why they introduced us 128-bit. Why not more than 128-bit? Exactly why 128-bit? Like this questions people they will ask. Why? Because our smart devices, it will support till 128-bit. More than 128-bit, it won't support. Your laptop, your mobile phone, everything it is going to support till 128-bit. So that's why till the end they introduced to us IPv6. We have more than 4 times IPv4, right? I hope you got it, guys. Still, India like countries, they are using IPv4. So you need to ask one question now. Sir, you said as of now IPv4 range it got completed, so that's why they introduced to us IPv6. Who introduced to us IPv6 and IPv4? They means who? They. Who introduced to us? How you are getting the internet into your home? How you are going to get the internet into your home, guys? Huh? Broadband. ISP, right? Internet service providers, they are going to provide the internet to us, right? Those ISPs from there, where they are getting the internet? Don't know. Those ISPs from where they are getting internet? Who's providing the internet? Those people's only they are providing the IPv4 and IPv6. So from where we are getting internet? Huh? Geo. Geo. Huh? See, guys, ICANN. From where we are getting internet? ICANN, the Internet Corporation for Assigned Names and Numbers. This guy, he is going to provide the internet. Got it, guys? This organization, ICANN. ICANN to INA. Under the ocean only, man. So who's providing? I'm asking about that particular organization. Cables under the ocean itself only we are going to get. Okay. The organization name we should have now. One. ICANN, the Internet Corporation for Assigned Names and Numbers. ICANN to INA. INA stands for IANA. Most of the people they know about INA. Who's into real time? Those people they know. Many people they know about INA. So IANA stands for Internet Assigned Numbers Authority. If you want, you can say INA also. It's not a problem. Right answer. No need to say ICANN. Few people they don't know much about ICANN. Most of the people they know about INA. So INA stands for Internet Assigned Numbers Authority. INA to RIR. RIR stands for Regional Internet Registry. RIR to ISPs like Jio, Airtel, Hathway, Act. We have many, right? So Geo Fiber like that we'll have, right? So I hope you're clear, guys. ISPs to small ISPs and there to into our home. Who provided IPv4, IPv6? INA or ICANN, you can say. It's not a problem. I hope you got it, guys. So they means INA. So let's see, guys, here. IPv4 having drawback. Drawback in the sense the combinations it got completed, right? It got finished. So that's why they introduced was IPv6. But India like countries, guys, listen. But coming to India like countries, not only India, many countries still they're using IPv4. Then how? Sir, you said as of now, IPv4 range, it got finished. We doesn't have the IP addresses in IPv4. So how India like countries still they are using IPv4 with the help of NAT concept. Got it, guys? Using NAT concept. NAT stands for Network Address Translator. NAT stands for Network Address Translator. With the help of one public IP address, we have two types of IP addresses. One is public, another one is private. Remember, public for internet, private for intranet. Got it, guys? So public for internet purpose. Public IP addresses are internet purpose. To get the internet, to communicate through internet. So private IP addresses for internal purpose. Private IP addresses, internal purpose. Inside our home, we are going to communicate. So for example, inside our home, we'll have two different laptops. If you need to send the data from one laptop to another laptop, with the help of private IP address, we are going to send inside our home. If you need to send the data from your home to another home, maybe some different person, we are going to use public network, internet. I hope you got it, guys. With one public IP address, we are going to communicate with 60,000 hosts. 60,000 hosts in the sense 60,000 private IP addresses. With the help of NAT concept, still India like countries, they're using IPv4. I hope you got it, guys. Yes, no? Clear? So how India like countries, they're using IPv4 with the help of NAT concept. How many types of IP addresses we have? What are they? Public IP address and private IP address. With one public IP address, how many hosts we can communicate? 60,000 hosts we can communicate with one public IP address. So public IP address is not free. Static IP address we need to purchase from ISP. They will charge 5,000, 6,000 per month. Like the same way, while we are discussing about NAT concept, I'll teach you about elastic IP address. They are going to charge for that. Practically, I'll show you NAT concept. Don't worry. Got it, guys? First, you need to understand the theory. Then only we are going to discuss about practicals, right? So clear? So coming to IPv4, now we are going to focus on where IPv4. So we are sending on Gmail. This is a public. Yes, always without internet, can you send the Gmail? If you're having internet means with the help of public IP address only, you are going to get the internet. Simple, ma. You are into your home. Your home is private. For you only, na. You need to travel from your home to Naresh IT classroom. So you are going to use one route, right? That route is a public. The route only for you. The route for everyone, right? That is public. So public is the internet. If you need to travel from your home to Naresh IT classroom, always you should use that particular route. The route anybody can use, right? I hope you got it now. Mahi. Right. Now we are going to discuss about IPv4. IPv4 is a 32-bit addressing. IPv4 is a 32-bit addressing, guys. Right? 32-bit means 32 zeros and ones. 32 zeros and ones. Got it, guys? 32 zeros and ones. So that 2 to the power of 32. How many combinations? More than 4 billion combinations we have. Who's going to use more than 4 billion combinations into one network? Tell me. No one, right? It's a very huge combination, right? So that's why ICNN or INA, whatever it may be. So those all the 32 bits, they got divided into 4 octets. OCTET. Few people they are going to call groups, but don't use group word. That is not a technical word. We need to call octet. Got it, guys? Total 32 bits, zeros and ones. It's a very huge combination. So that's why INA what they did, they got divided into 4 octets. ICN and INA, they got divided into 4 octets. So each octet having 8 bits. 32 divided by 4. That's it, na? 32 divided by 4. So each octet having how many bits? 8 bits. So first octet, 8 bits. Second octet, 8 bits. Third octet, 8 bits. And fourth octet also 8 bits. Those octets, it got divided with the help of decimal dot notation. So this octet and this octet, it will divide with the help of decimal dot notation. And this octet and this octet, it will divide with the help of this decimal dot notation. And this octet and this octet will divide with the help of this decimal dot notation. So that's why our IP address, it will be looking like this. 192.168.1.11, 1.12, 1.14, 1.16, 1.18 like that. I hope you got it, guys. Why our IP address, it will be looking like that means because total 32 bit, it's a very huge combination. They got divided into 4 octets. Each octet, they means INA, ICNN. They got divided into 4 octets. Each octet having 8 bits. Each octet, it will divide with the help of decimal dot notation. So that's why our IP addresses, it will be looking like 192.168.1.11 like that. Guys, if you want to can convert this binary value into numerical, you are going to get one numerical value. But this is not exact value, guys. Just for understanding purpose, I made that. So clear, guys. So this 8 bits, if you're converting into the numerical, we'll have the binary calculators in Google. Open the binary calculator. Those 8 bits you can provide into the binary calculator. It is going to convert into the binary to numerical. So you are going to get one numerical value here. I hope you got it, guys, right? So each octet having how many bits? 8 bits, right? Can we write 2 to the power of 8 formula instead of 2 to the power of 32? Usually 2 to the power of 32, right? 32 bit means. Now we have only 8 bits now. Each octet having 8 bits, right? So can we write like this 2 to the power of 8? Yes, we can. So 2 to the power of 8 is equal to how much? 256 combinations. So if you are writing 0 to, we are going to get 255 only because we need to do -1 because we are writing from 0. I hope you got it, guys. 0 to 255 combination. So this octet having 0 to 255. This octet also having 0 to 255. And this one also having 0 to 255. And fourth octet also having 0 to 255. I hope you're clear, guys. First octet, 0 to 255 combinations. Second octet, 0 to 255 combination. Third octet, 0 to 255 combination. And fourth octet also having 0 to 255. First octet, how many combinations? 0 to 255. Second octet, also having 0 to 255. Third octet having 0 to 255. And fourth octet also having 0 to 255. 0 to 255 also, it's a very huge combination. No one they are going to connect into each network more than 200 missions. Got it, guys? 0 to 255 also, it's a very huge combination. So that's why INA, they introduced to us IP address classification. First, 32 bits. It's a very huge combination. More than 4 billion combinations we have. So ICN and INA, what they did? They got divided into 4 octets. Each octet having 8 bits. Right? So 8-bit means 2 to the power of 8. So 2 to the power of 8 means 256 combination. If you are writing from 0 to 255. So 255 also, it's a very huge combination. So that's why ICN and INA, what they did? They introduced to us IP address classification. Classes, class A, class B, class C, class D, and class E. 5 classes. I hope you got it, guys. Right? So simple. Assume this building space 4,000 square feet. So if you are try to making one classroom, it's not worthable for us. So that's why what we are doing. So this is a very huge space, right? We are trying to making 5 classrooms. I hope you got it, guys. So class A, 0 to 255, right? Class A, 0 to 127. Class B, 128 to 191. Class C, 192 to 223. Class D, 224 to 239. Class E, 240 to 255. Total 0 to 255. Total 0 to 255, they got divided into how many classes? 5 classes. Class A, 0 to 127. Class B, 128 to 191. Class C, 192 to 223. Class D, 224 to 239. Class E, 240 to 255. 0 to 255. Guys, so sir, so right now we have listen, everything you are going to understand, Shekhar. First of all, let it complete this entire concept. Then only you are going to understand. You have some confusion now. Okay. Which octet we are going to use like that you are asking. So let it complete, then you are going to understand. Right. So guys, class A, class A, class B, class C. First 3 classes we are going to use for LAN and WAN purpose. Got it, guys? Only class A, class B, class C, we are going to use for whom? LAN and WAN purpose. To deploy the network into our organization, into cloud environment, we are going to use only 3 classes. First 3 classes, class A, class B, and class C. Those 3 classes for whom? LAN and WAN purpose. Who's going to manage the LAN and WAN? We only. I hope you got it, guys. We are going to manage the LAN and WAN. Class D and class E. Class D for multicasting purpose. As of now, how many? We discuss communications, broadcasting, floating, unicast, and multicast. Broadcasting means 1 to many including source. Floating means 1 to many excluding source. Unicast means 1-to-1 communication. Multicast means 1-to-1 group. In our class, we have multicast only. So what I'm doing, I'm trying to teaching for one group of people. So one mission to one group of missions, we are going to send the data. That is called multicasting. We are not going to bother about multicasting. And class E for research and development purpose, R&D purpose. And class E also we are not going to use. I hope you're clear, guys. Class A, class B, class C. Only first 3 classes we are going to use to deploy the network. Class D for multicasting. Class E for research and development purpose. Simple, man. I'm a faculty. I'm going to bother about classrooms. That's it, right? I'm not going to bother about front office, right? I hope you're clear. Assume that Naresh Shetty having 5 classrooms in that one building. So class A, class B, class C, those for teaching. Class D for reception. Class E for another reception. As a faculty, I am going to bother about classrooms. I am not going to visit to the front office. So that's why we are not going to bother about class D and class C. I hope you're clear, guys. Yes, no? Good. So, guys, now you need to get one doubt. And one more thing, don't by heart this. Class A 0 to 127, class B 120 to 191, like this. Many people, they are going to by heart. Don't do like that. We need to understand the concept, then only we are going to deploy the proper network. Otherwise, you are going to lose the job. I hope you got it, guys, right? So let's see, guys, here. 0 to 127 class A. Why 0 to 127? Why not 0 to 191? In which basis INA they define the classification with the help of priority bit. What is that? Priority bit. IP address classification done by using priority bit. Clear, guys? IP address classification done by using priority bit. IP address classification done by using priority bit. What is priority bit? What is priority bit? Most significant bit of the first octet. Most significant bit of the first octet we are going to consider as a priority bit. Got it, guys? Most significant bit of the first octet we are going to consider as a priority bit. I hope you're clear. So this is a most significant bit of the first octet, 0. Got it, guys? How we are going to get the most significant bit of the first octet, that is also I will teach you, don't worry. With the help of binary calculation. With the help of binary calculation, we are going to get the most significant bit of the first octet. We are going to call as a priority bit. Got it, guys? 0 is a priority bit for class A. So with the 0, they decide 0 to 127. Got it, guys? 10 is a priority bit for class B. 110 is a priority bit for class C. 1110 is a priority bit for class D. 1111 is a priority bit for class C. I hope you got it, guys. 0 is a priority bit for class A. 10 is a priority bit for class B. 110 is a priority bit for class C. 1110 is a priority bit for class D. And 1111 is a priority bit for class C. Got it, guys? Right. So how you are going to get this priority bits? With the help of binary calculation. How many of you know about binary calculations? So few people, they know, right? So who don't know, let's see here. This is numerical calculation, right? 2 to the power of 2 is equal to 4. 2 to the power of 2 is equal to 4. 2 to the power of 2 means 2 bits, right? Total value 4, right? So can we write this numerical calculation into binary? Yes, we can. So 2 to the power of 2 means 2 bits. First combination 0, 0. First combination 2 bits, right? 1, 0, another 0, 0, 0, 2 bits is equal to 0. Second combination 0, 1. 0, 1 is equal to 1. Third combination 1, 0 is equal to 2. And final 1, 1. After 1, 1, can we write any combination here? I hope you're clear, guys. So total how many combinations? 4. So 2 to the power of 2 is equal to 4. It got satisfied, right? The same logic we are going to apply for this octet. So this octet having how many bits? Can we write 2 to the power of 8? That's it now. So 2 to the power of 8 is equal to 255. So now 8 bits, right? First combination 8 zeros is equal to 0. And second combination 7 zeros 1 is equal to 1. 6 0 1 is 0 is equal to 2. Like this, if you are try to calculating in one place, first bit it will become 0 and remaining all it will become ones, that is 127. So this is a most significant bit of the first octet. We are considering as a priority bit for class A range 0 to 127. I hope you got it, guys. Who know binary calculation, those people, I hope they got right. Don't worry, remaining people. We have Imran sir calculation. I'll teach you. Then easily you are going to understand. Imran sir means nene. Okay, na? Right. So let's see, guys, here. Right. So next combination 1. After that, everything it will become zeros. Then 128. Then 190, 129. Like this, if you try to calculating, first 2 bits 1 0. After the 0, it will become ones. That is 191. So that's why class B priority bit is a 10. Range 128 to 191. Next, if you try to calculating like the same way, you are going to get the 110 and then 1110. And guys, remember 8 ones is equal to 255. 8 ones value, 8 ones binary value, if you are converting into numerical value, it will become 255. So if you find 8 ones, Nina, I'm asking about you. I have soft eye, no, right? मैं किधर देख रहा हूँ बोल के समझ में आ रहा है ना? Then you only. Why you are sleeping? Yesterday which web series? Huh? Right. So let's see, guys, here. Okay. ये लोग कुछ काम के नहीं, एटलीस्ट आप तो भी सुन रहे हैं. जो लोग ई बोल रहे हैं ना, वो लोग कुछ काम के ही नहीं है. एटलीस्ट आप तो बीच में जो है ना सुन रहे हैं. सो आई थिंक यू आर वेरी टाइर्ड, राइट? नो, नॉट यू मा. अभी देख रहे हैं. सो बिकॉज ऑफ स्पेट्स आई थिंक यू आर अनेबल टू फाइंड. मैं जो बोल रहा हूँ फर्स्ट रो में है ना, उनको बोल रहा हूँ डोंट स्लीप. ओके, राइट. कल से right, guys. Let's see, guys. Yeah. So I hope you clear how we are going to get the priority bits. So how that got divided into the multiple classes? With whom they got divided into the multiple classes? With the help of priority bit. What is priority bit? Most significant bit of the first octet we are considering as a priority bit. Right? I think time up. Don't worry. Tomorrow I'll teach you my calculation. It's very easy. No need to bother about binary calculation. Who don't know much about binary calculation, for them it's very easy. So actually this calculation, it belongs to me. Copyrights, it belongs to me only. Right? Got it, guys? So my research karke, while I'm trying to starting the job at the time. So this is very easy to you people to understand. Right? So it's very easy to understand. So easily you are going to get the, guys, 1 minute, guys, chhod dunga. Okay, so don't miss tomorrow. Tomorrow is the last theory. Tomorrow is the last theory. It's a very, very important theory. Right? Without knowing subnetting, you are unable to create the subnets into VPCs. Those all pre-requirements. So usually most of the people, they won't teach. Directly they are going to start the AWS. So if I'm starting like that, you are unable to understand, there is no use. So blindly you are going to perform the task. But you need to understand thoroughly what we are learning. We are learning little bit only. But the little bit also we need to learn properly. Got it, guys? So please Don't miss. Tomorrow is the last theory. From day after tomorrow onwards, I am going to start the practical session. How to create the account, everything we are going to discuss day after tomorrow, right? So Saturday भी रहेगा यार. Where to attend offline? Come to new building beside Satyam Theatre, AAA. Beside AAA. Thank you for being helpful in everything. So thank you, Mama. Welcome. Okay, guys. See you tomorrow. Bye. Take care.